Good morning, students. For the last class, we had seen that Newton's laws and applications of Newton's laws, right? So in that applications, we had seen the free body diagram. Okay. So based on free body diagram, here the next topic is particle moving in an inclined plane. Okay. So just consider this is an inclined plane. It makes an angle what? Theta here. Okay. So here we kept an object of mass m, and this object of mass m, it slides on a frictionless surface. Okay, which means the object is moving, there will be a acceleration. So that we put what is it here? A vector. Okay, and here this S mentions the length of the inclined surface, right? And this H is the height and here is the length, right? So here what we are going to find out here. Whenever the object is moving and here the force decides the what is the acceleration of the object and what is the speed of the object. Okay, so here we are going to find out what is the acceleration of the object and what is the speed of the object when the object reaches the water. Okay, which means we are going to find out what is A and what is speed, that is velocity V. Okay, so first initially here the force, what are the forces acting on the object? Which means here there are two forces acting on the object. Generally we know it. What is that? Downward gravitational force, that is mg force, and another force is a normal force, that is n. Okay, so in that we can see here, and this is a free body diagram. So which means whenever the block of mass m, we have to assume to be a point mass when we use to draw a free body diagram. That we know it generally, right? So this block of mass m is assumed to be what is it here? Point mass, that is m here. Okay, so one is a downward gravitational force acting downwards here, and another one is a normal force, right? And here next thing is, and this downward gravitational force is resolved into two components. One is a parallel component and another one is what is that? Perpendicular component. Okay, so this mg sin theta is acting along the surface, right? Which means that is a parallel component here. Okay, and this mg cos theta is acting perpendicular to the surface. Okay, so that is mg cos theta perpendicular to the surface here. Okay, so one is mg sin theta, that is parallel component, and another one is what here? mg cos theta, that is perpendicular component. Okay, so here there is a free body diagram, and this diagram is what? mg is drawn into parallel and perpendicular component here. Okay, so in that what we are going to see here? Listen, this is the x coordinate, and here what is it here? Y coordinate. And we know it, when the object start to slide means there will be an acceleration acting along what is it here? Only in x direction. Which means the object can be moving like this. Yes or no? Yes. Which means there is no motion is acting along the y direction. Okay. So in this we have to resolve two components in two terms. One is the y direction term, another one is what is that? X direction term. So first we will see what is that? Y direction term. Okay. So in y direction we are going to apply Newton's second law. That is, we know F vector equal to m into what? A vector. Okay, this F is a total force here. So in y direction, there will be two forces acting here, right? So one is a normal force, another one is what is that? mg cos theta force, right? This normal force is acting along the positive y direction, yes? And this mg cos theta is acting along the negative y direction. Okay, so whenever we have to add these two forces, we can get what? Total force. Okay, so F vector is nothing but minus of mg cos theta, because mg cos theta is acting along negative direction. Okay, so minus mg cos theta j cap. Why I put j cap here? In terms of vector notation, we have to put what? Unit vector here. So in y direction, the unit vector is what? J cap. Okay. So minus mg cos theta j cap plus normal force j cap, that is n j cap, okay, equal to m into a vector, right? And I said that there is no acceleration acting along the y direction, right? Which means what? A is equal to 0. So this term gets what? 0 here. Okay. So by comparing the components on both sides, what will you get? This n minus of mg cos theta equal to what? 0 here. So with this term mg cos theta, can put that term. What will you get now? N equal to mg cos theta, which means the normal force is exerted by what is that? Equal to mg cos theta. This normal force is exactly equal to what is it here? Mg cos theta force here. Okay. And next thing is in x direction, and I said the object is moving along in what is that? X direction only, which means there is an acceleration in the x direction. Okay. So in x direction, the same thing we are applying what? Newton's second law of motion. The formula is F vector equal to m into a vector. Okay. This F is a total force I said. Okay. In x direction, there is only one force is acting. What is it here? Mg sin theta force. Okay. So mg sin theta I cap. Why we put I cap here? Because in x direction, the unit vector is I cap. Okay. So mg sin theta I cap equal to ma into I cap. Okay. So by comparing the components on both sides, we get mg sin theta equal to m into a. Okay. So this m and m gets cancelled, remaining a equal to g sin theta. So the acceleration of the object a could be equal to what is that? G sin theta. Because the acceleration is acting along the x direction, which means that is a is not equal to 0 here. So we get a equal to g sin theta. Right? Suppose when the angle theta could be equal to 90 degree. When the theta angle of inclination is equal to 90 degree, means what will you get now? Sin 90 becomes what? 1. So we get a equal to g, which means the acceleration is exactly equal to what is that? Gravitational force. That is g here. Okay. So we got what is the acceleration of the object. So a equal to g sin theta. Right? So next we have to find out what is the speed of the object when it reaches the bottom. Speed means what here? Velocity. Right? So we are introducing the kinematic equations. That is v square equal to u square plus 2as. Right? So v is the final velocity, u is the initial velocity, and a is acceleration. S is what is it here? Displacement. That is length here. Right? So we know generally initial velocity could be equal to what? 0. So this terms get 0. So v square equal to 2as. So we want to know what is v only. Okay. So v equal to root of 2as. Right? So we got already a value. What is a we got here? A equal to g sin theta. Right? So we just substituting here. So v equal to root of 2sg sin theta. Okay. This is the equation for the speed of object when it reaches the bottom, which means the particle moving in a inclined plane, the velocity value is root of 2sg sin theta. And the acceleration is a equal to g sin theta. Okay. The next topic is two bodies in contact with each other on a horizontal surface. Okay. So you just consider two bodies of block of masses m1 and m2. And these two bodies should keep contact with each other on a smooth horizontal frictionless surface. Okay. So these two bodies having masses m1 and m2. Right? So here the external force is applied on this block of masses. What will happen? So this body can make to move. Right? So at that time the body m1 will exert a force on the block of mass m2. Right? So the same time the block of mass m2 will exert the equal and opposite force on the block of mass what? m1. Right? So that the force is what here? F12, and here this force is F21 here. Right? So initially m1 is greater than what is it here? m2. Right? So when we apply the external force F here, at that time there will be a acceleration because the two blocks are made to what? Moving here. Okay. So this F and A both acting in the same direction only. Right? So according to Newton's second law, we know F vector equal to m into A vector. Right? So in terms of vector, we have to put what here? Unit vector here. Right? So F I cap equal to ma into I cap. Why we put I cap here? Because the external force F is acting along the positive x direction. Because in x direction means the unit vector is what here? I cap. Right? So F I cap equal to ma into I cap. Okay, so by comparing the components on both sides, we get F equal to what? Ma. Okay, so this M is the total mass, which means when we add these two block of masses, we can get what? Total mass here. So M equal to M1 plus M2, right? So we are applying M1 plus M2 instead of M here. We get what? F equal to M1 plus M2 into A. Okay, so from this we have to find out what is the acceleration, right? So by doing reverse multiplication, we get A equal to F by M1 plus M2. So we got what is the acceleration of the object here, which means object means both the masses M1 and M2, right? So next thing is we just consider for one block, that is for body of mass M1 here. Okay, so this is for block of mass M1, which means the F force is acting along the positive x direction, and here the F12 force is acting along the negative x direction here. Okay, so this is the free body diagram, which means we have to consider the block of mass to be what here? Point mass. That is a point mass M1 here. Okay, so which means the F force is acting along the positive x direction, and the F12 force is acting along the negative x direction. Okay, and in upwards normal force is acting, and downwards what? Gravitational force is acting. And we know it what? This normal force is exactly equal to downward gravitational force. That is what we had seen in the last topic, right? So M could be equal to what? M1G we can get simply. Okay, so now we have to find out what is the F12. Because in Newton's third law we know for every action there is an equal and opposite reaction. That is, we are going to confirm here the Newton's third law, which means this F12 vector would be equal to minus of F21 vector. We are going to confirm this Newton's third law here. Okay, so which means we have to know first thing is what is F12, right? So instead I just applying the Newton's second law here, that is F vector equal to M into A vector. Okay, so this F is the total force, this A is what is it here? Acceleration, and M is the mass. So in this block of mass M, what are the forces acting here? We know it two forces acting here. One is the external F force, that is horizontal force, and one is what here? F12 force. Okay, but this F force acting the positive direction, and this F12 is along negative x direction. So if we add these two forces, we can get what? Total force here. So I put simply F I cap minus of F12 I cap, because acting negative x direction here. So then I put what here? Minus F12 I cap equal to Ma, which means for block of mass M1. So I put what here? M1A into I cap, because acceleration is acting along the positive x only. So I put plus I cap here. Okay, and next step is what? We have to compare the components on both sides. So we get F minus F12 equal to M1A. Okay, I just want to know what is F12 only. So minus of F12 equal to M1A minus of F here. Okay, so here minus sign is here. I just want to in plus sign, right? So F12 equal to, we have to interchange it here. So F minus M1A. Okay, so already we got what is the acceleration equation. What is it we got in the first equation, right? So A equal to F by M1 plus M2. So we just substituting here. Okay, substitute 1 and 2. We get what? F12 equal to minus of M1 into F by M1 plus M2. Okay, so here you see, and here also is F, here also is what is it here? F. So I taken outside commonly. The remaining term is 1 minus M1 by M1 plus M2. Okay, so next thing is, we just doing cross multiplication. We get what? F12 equal to F into M1 plus M2 minus M1 by M1 plus M2. Okay, so this plus M1 minus M1 gets cancelled. The remaining term is F12 equal to F into M2 by M1 plus M2. So we got what is F12. Okay. So in this is we got in aptitude term, right? So in vector notation, the equation can be changed as what? In vector notation, this F12 vector is equal to minus of F_m2 by M1 plus M2 into I cap. How do I get here? Minus sign. Because this F12 you see here, it is acting in the negative x direction. Okay, so I put minus I cap here. So minus of Fm2 by m1 plus m2 into I cap. Okay, so we got what is F12 equation, right? So the next case is what? We have to consider the block of mass what? M2. So here for mass M2, there is a diagram here, and mass M2 here. There is only one force is acting on the block of mass M2 here, right? So what is the force here? That is F21 force. Okay. So this is a free body diagram. So we have to assume to be the mass M2 is what is that? Point mass here. Okay. So this is a point mass of M2. So only one force is acting, that is 21 force here. And this F21 force is acting along the positive x direction. So it is positive x direction here. Okay. So in the normal force is acting upwards, and in downwards what is it here? Gravitational force is acting. That is m2g force. And here also the same thing. This normal force is exactly equal to what is that? Downward gravitational force. That is n would be equal to m2 into g. That we know it. And here we have to find out what here? What is F21 vector? Okay, so that is the same case we can apply what we applied it for M1. The same thing have to apply what is that? M2 here. So the same, applying it in second law here. So F vector equal to M into A vector. So this F is a force here. So I said only one force is acting, that is F21 force in the positive x direction. So I put plus I cap here. Okay. So F21 I cap equal to MA into I cap. So F12 I cap equal to M2A into what? I cap. Right? So by comparing the components on both sides, we get what? F12 equal to M2 into A. Okay. So already we got what is A here. Because A equation we found in F by what? M1 plus M2. So we are substituting here. We get F12 equal to M2 into F by M1 plus M2. So the same thing F12 equal to Fm2 by M1 plus M2. This is what we get in what? F21 vector also. Right? So in vector notation, the equation becomes F12 vector equal to Fm2 by M1 plus M2. Okay. Into I cap. Right? So here we put only positive I cap here because F12 is acting along the positive x direction here. So from this we have to note it down. This F12 vector is minus of F21 vector, which means what? Which confirms the Newton's third law here. Because Newton's third law formulas F12 vector equal to minus of F21 vector. So whenever this two body which means contact between each other, it said to be in motion, we found that F12 equal to minus of F21. It confirms Newton's third law of motion.